everyone. This video will teach you how to graph functions using your graphing calculator. So what I'm going to work through with you today is through page 5 of your note packet. We're going to work through a few examples that are relevant to what you've recently learned, which is how to graph quadratic functions in Vertex form, as well as how to graph absolute value functions. I'm going to show you how to use your graphing calculator to work with those types of functions, and these skills in general will be very useful throughout the year, as we're going to graph all types of different things. And we're going to use a lot of these same button presses, and not only for this chapter, but in moving forward. So there are instructions at the top half of the page that hopefully you can kind of keep maybe off to the side here as you're working through, and you can see that here on your screen. But before we get into any graphing whatsoever, I'm going to highly suggest that you clear the memory of your calculator, especially if it's one that you've borrowed from the school or you've borrowed from a friend or a sibling. Because oftentimes what happens is you end up getting a lot of extra information, people just randomly pressing buttons, and there's information all over the place. So before we get into this here, let's clear the memory on your calculator. Okay, if you watch the screen, the buttons I'm clicking here, you'll see under key press history what buttons to hit, so you can pause it and just look at the order of the buttons I'm hitting. To clear the memory on your calculator, you're going to press second plus 7 1 2. Once you clear the memory, it'll say something to the effect of RAM cleared. Again, I'm using a TI-84 Plus calculator emulator here, so it might not be the exact same messaging on your screen, but it'll say something to the effect of RAM cleared, which means your memory's cleared, all the settings have been set back to normal, and that'll make it a lot easier for us to graph and have everything cleared out. So what we're going to take a look at here are several examples, and these steps that I have listed here, this will be helpful when you try to reference this on your own. But basically, I'm going to go through these steps. You'll see here on the screen what buttons here to press, and hopefully you'll be able to piece these things together. So let's go ahead. I'm going to clear this out. I'm going to clear the button history here so we have one less thing. And let's take a look here at the first example. So with each of these here, now there's a bunch of info we can find. And we talked about that a lot yesterday, where, you know, we can identify A values, we can find minimums and maximums and all kinds of stuff. For the purpose of focusing more on pressing the buttons in the calculator, we're going to focus on two main things. We're going to focus on finding the vertex and finding the Y-intercept. And again, there is more information I can certainly make you find. Using the calculator will help you with some of these things as well. But this is enough here to kind of fit on the page. So again, we're going to limit the info we're going to find. Here's how we're going to graph. So we're going to start here with some quadratic functions. These are the things you learned most recently here in numbers 1 through 3. So the first thing that I want to do here is I want to punch this in. To punch in an equation in the graph, you want to go to the top left corner of your calculator and hit y equals. Now again, mine is a color version. If you have a slightly older calculator, the TI-83, this will not be in color, but again, it doesn't matter. All works the same. So we're going to put things in the Y1 slot, okay? And we're going to type in everything after the Y equals sign. So we're going to type in the x plus 3 squared minus 2. So you want to make sure to punch everything in as you see it. So we've got the X button, okay, towards, that's near the alpha key, okay? We've got, okay, plus 3 parentheses. Want to make sure we hit squared, okay, minus 2. And make sure with minus, we're using the subtraction sign, not the negative sign. That will make a huge difference in how your graph will plot. So once we graph, punch in the equation, we're going to hit the graph button in the top right, and you'll see a very nice picture of it, okay? So we got our parabola, and what we're going to do is we're going to take the info from that, transfer it on paper here so we can actually plot the graph. Here's how you do that. You hit second and the graph button again. That'll bring up the table, and you'll see that in blue or a very similar color written above graph. Again, second graph will take you to the table. Now, this table is an infinite list of x and y values that will work in this equation. But ultimately, we only want ones that we can actually fit on our graph. Where I'm going to start with actually is with the vertex before anything else, because the vertex we can identify without having to go through a crazy amount of math here, okay? And that'll also help us figure out where to zoom in on our table. So if I look at the equation, based on what we talked about the last few days here, the vertex based on this equation is at -3, -2. So I can go ahead and plot that, and what that allows me to do is in my table, I can use the cursors to scroll up a little bit here and go find -3, -2, as you can see that I have highlighted. Now, the reason why I want to find that is because to find more points, this table has an infinite amount of them. But when I find the vertex, I'm going to use the points that surround it in order to come up with my table of values that make it easy for me to plot my graph. So what I'm going to do here is create a table where I'm going to choose the 2 points that are above it physically on the table and the 2 points below. Because you'll notice, if I look at the y values, they start wrapping around each other. The vertex is the middle of it, and then the y values kind of repeat in opposite directions. So I'm going to copy those handful of values into my table, as you can see, and then I'm going to go ahead and plot them. And once I do that, I've got my parabola. I can even look back at the graph and say, that looks like it's in roughly the same location. This graph is a 10 by 10 grid, even though it's a little stretched out here. It can kind of skew it a little bit, but it is a 10 by 10 grid. It's in roughly the right spot. Looks the same. That's pretty good. The other piece of info we're going to identify is the Y-intercept, which again, second graph, we'll go back to our table. The Y-intercept, remember, Y-intercept always has an X value of 0. So even though it might be tougher to see on the graph, we don't need to worry about trying to guess where it's at. We can go ahead to the table and say, okay, well, if the X has to be 0, the Y value is 7, that's going to be our Y-intercept, 0, 7. Now, again, we can find other information. I can make you identify the A value. We can do min and max and all that stuff. But your calculator, you see how that shortcuts a lot of the information. Where, again, we were doing some guessing and checking. We were plugging in different numbers to try to get all these different points. With the calculator, you won't necessarily have to do that. So we're going to go ahead and repeat this process here for these other problems here. So, again, the key is you got to make sure you punch them in right. So we're going to go to number 2. So I'm going to create a new graph here. So I'm going to hit y equals. I'm going to clear out that y1 line. Okay, you should always clear out the equation so you can type in a new one. So we're going to go ahead and type in -2 parentheses x minus 1 squared plus 5. Now, I can hit graph so I can see the picture. Okay, so we can see the parabola there. We got it's upside down, which makes sense because the a value is -2. Now, before we even get into the table, if I look at my equation, and again, you can look on the screen or on the paper, we should be able to pull the vertex from this really easily. The vertex is going to be, again, based on this vertex form, at 1, 5. Okay, so you can see where I plot that. If I look at the graph, you can see where it kind of tops out here, and it's roughly at about 1, 5. Well, it is at 1, 5, and you can trace that on your calculator. So I'm going to go ahead to my table of values by going to second and graph. What I want to look for is the ordered pair 1, 5, which I've got highlighted here. And again, to fill in my table of values, pick the 2 numbers that come before it and the 2 numbers that come after it, and use those values to fill in the table. So as you can see here, I'm going to fill that in, and then I'm going to plot all those points and connect them together. So again, all I'm doing is pulling that information. I don't need to plug in any numbers into my equation to figure that out. It's all there and done for us. Again, there's an infinite list. You want to zoom in on where's the vertex at, pull the couple of numbers before it, and pull the couple of numbers after it. Now, last little bit of info here is the y-intercept. And again, the y-intercept is when x is 0, what is y? That's already one of the points that fits on your table, so that should make it a little easier to identify. When x is 0, the y is 3. The intercept would be at 0, 3. Again, if we look at our graph, it matches there. The last problem we'll do here with the quadratic functions is number 3. So once again, I'm going to go back to y equals, clear it out. So we have a fraction here. You can do this in a couple of ways, depending on your calculator. If you have an 84, you have that secret little fraction menu by hitting the green button alpha and y equals, then enter, and it allows you to type in fractions really nicely. That is if you have an 84, you can do this. So I'm going to go ahead and show you how to type all this in with an 84. So the rest of it's the same stuff. Parentheses x plus 6, close it off, put your exponent after it, and that's good. If you have a TI-83, or maybe an older 84 that maybe doesn't have that update built into it for some reason, you may not be able to enter that nice little fraction form. The other way that you can do this, so I'm actually going to go ahead and clear this whole line out, is you can put the fraction in parentheses by doing 3 divided by 4. That'll still function as 3/4. You want to make sure to put it in parentheses just to make sure no math gets screwed up. But that is a way you can work around it as well. Okay, and again, if you have the 83, you have no choice but to do that. Okay, or you could always enter it 3/4 as a decimal, 0.75. That'll work the same way. No matter how you enter it, okay, any of those ways I just showed you or described to you will work. Okay, I can again show you the graph. You can see where it's located. If I look at the equation, I can pull the vertex from it. It's going to be at -6, 0. Again, based on the vertex form, so you can see where the starting point is. And then if I look at my graph, we can clearly see, because it's on the axis here, it's at -6, 0. It bottoms out there. So we need more points. Second graph, we go to our table. So again, I want to focus in on -6, 0. And again, I want to pull the couple of values that come before it and a couple of values that come after it. So that way I have 5 total points. So I'm going to go ahead and fill in my table and plot my graph. Again, it's all roughly in the right spot. Everything matches up. Life is good. Last bit of info to fill in based on what I'm asking here is that Y-intercept. So I'll go back to the table. Again, Y-intercept means x is 0. The y value is 27. So I know that seems a little weird because all the other intercepts have been like very small numbers. For this graph, it makes sense though, because look at what's pictured here. Okay, if I go back to the graph itself, okay, it's going to take a little while before that line ends up crossing the y-axis. You end up going off the screen here. So again, the beauty of doing this on the calculator is that you can have some of these answers where it would be a lot harder to visually see and pull the point from, rather than just let the calculator do its magic here and work through the numbers for you. But the y-intercept is correct. It would be at 0.27, just pulling that straight from the calculator table. So that's how you enter quadratic functions. The other thing we're going to take a look at here is how to enter in these absolute value functions. It's mostly the same process here, but we've got to do one little extra step to show absolute value. So once again, I'm going to clear my function here. Here's number 4. So y equals -1/2 absolute value of x plus 6. So I'm going to go ahead and enter my fraction first. And since I got the fancy menu, I'm going to go ahead and do -1/2. So put the negative out front here. 1/2. To pull up an absolute value bar, okay? If you use parentheses, this will not be done correctly. You must access the absolute value bar. On an 84 or an 83, you'll get to it the same way. It just will look different depending on your calculator. So to get to the absolute value bar, you must press Math. You will scroll across to where it says NUM for the number function menu. The first option says ABS, that stands for absolute value. You're going to go ahead and hit Enter. On an updated 84, you'll actually physically see the bars. If it's an 83, it's going to say ABS with a parentheses after it, okay? So that might look a little confusing because if it's absolute value, well, why is that parentheses? It's an older calculator. That's how it knows to still do absolute value even though parentheses are involved. So whatever's in the bars, I'll stick in between. So in this case, it's just an X, and I'll use my cursor to get out of it once I've filled in the bars. If you, again, have an 83 and it just says ABS with the parentheses, you'll want to close off the parentheses there once you enter in what should go inside. Again, ABS with parentheses will tell the calculator to do absolute value. We type in the +6, and we graph. So we get ourselves a nice absolute value graph. You can see a very wide upside down V. And we're going to go ahead and identify the vertex. So based on the form, the vertex would be at 0,6. And you can see on our graph, it peaks at 0,6 and then it falls off on both sides. Let's go to our table. And so again, we'll go to 0,6 to kind of zoom in. Okay. Now, on your calculator, it might give you some of these values here for y as fractions. That's okay. That'll still work. You can list them out as fractions and convert them to decimals really quickly here, just using your calculator if you need to. You'll see here on my table, I've actually already made them decimals. So It all means the same thing, but ultimately you'll get your points. You can see how I filled everything in. Makes my graph. Now, the y-intercept, in this case, happens to be the same as the vertex because, again, y-intercept has an x value of 0. I already have that highlighted in my table, and you can clearly see on the graph if that's 0, 6. So for number 5 and number 6, we're going to go ahead and enter in. So for 5, we've got the absolute value of x minus 3 minus 7. So again, to get absolute value, so I cleared out. Let's go to math, number, enter. And we'll type in the x minus 3. Use our cursor, get out of the bars, and type minus 7. Here's my graph. So I get my nice V-shaped graph. Based on the equation, the vertex is positive 3, negative 7. And if I look at it here, again, I can kind of line it up here with my little marks here. Seems to be that the vertex is in the right spot. We're going to go ahead to our table. And again, I'm going to look for 3, negative 7. Pull a couple of numbers before, a couple of numbers after. You can fill in your table of values. Plot some points, make your graph. Again, if I will ask you to find the y-intercept, we can go to 0 on the table. Okay, so we got when 0 is x, negative 4 is y. That means your y-intercept is 0, negative 4. Which again, if you look at your graph here and you extend it out a little bit, that would fall in the pattern as well. And last but not least here, just so you can see it one more time, number 6. So we got 3 times the absolute value of x plus 2 minus 4. So again, we will go to, we'll type in the 3 first, then we hit math, number, enter. So this will know to do 3 times that absolute value. You don't have to put in a time symbol. We'll put in x plus 2 in the bars here, minus 4. Here's our graph. Again, if I look at the vertex form here, our vertex is at negative 2, negative 4. If I look at my graph, that lines up pretty nicely. Go back to our table, look for negative 2, negative 4. So I have it at the very top, so I'm going to scroll up a bit here just so I can get some values before and some values after it. And I copy them into my table. Get my graph. Again, we see how it matches the picture, which is great. My y-intercept, again, the x value has to be 0. That means we get a y value that corresponds with a 2. Y-intercept is 0, 2, which also happened to be one of the points in our table, so that lines up really nicely. So hopefully that was a thorough enough walkthrough on how to use your calculator to graph these functions. Again, if the verbal doesn't quite register here, if you go to the top half of this note page, it has everything spelled out for you. So if you're better with like reading directions and doing it that way, that'll also be there as a reference. So I would suggest definitely as you're practicing this, go back and forth. Again, really, if you can do one example, you can certainly do the rest of them. But definitely use this here as much as needed if you have any needs to figure out how to use your calculator. So as always, any questions, let me know. Otherwise, thanks for watching.